Hello students, welcome to this new lecture on digital communication. In this lecture we'll be discussing our syllabus of digital communication, and from the next lecture onwards we will go through the main topics. Okay, so first of all, in unit 1 we will be studying about sampling theorem for both low pass and band pass signals. Low pass means the signals which have lower frequencies, and band pass signals means which have higher frequencies, the signals with higher frequencies. Okay, so both have different sampling theorems. We'll learn the sampling theorems for both kinds of signals. Then comes ideal sampling, natural sampling, and flat top sampling. These are three types of samplings that we'll learn about, and what are the differences between these kinds of samplings, and all those things we'll see. Then comes time division multiplexing. Time division multiplexing is basically used when we are transmitting multiple signals through the same channel at different times. So that is why it is called time division multiplexing. Frame of time is divided into multiple, you can say, multiple parts, and each part is used to send a signal. So time division multiplexing will be studying. Then aliasing and crosstalk also will study. Crosstalk is a part of time division multiplexing which is a problem that happens in time division multiplexing sometimes if it is not done properly. Then aliasing is also one phenomena which is related to sampling. While sampling, if we don't have the proper sampling frequency, then aliasing may happen. So we'll study about that also. Then we have PAM, which is pulse amplitude modulation, pulse width modulation, and pulse position modulation. Their generation and detection will be studying, and we'll also be studying the relation between PWM and PPM, which are very closely related to each other. Then we'll also study the importance of PWM. We use PWM in modulation. This modulation, PWM modulation, we use it in motors for controlling the speed of the motors. So we'll see that also, how we do that and all those things. Then one more thing I would like to add now only, that the quiz that I talked about in the first chapter, in this discussion I'll be uh, having some quiz questions based on the full forms. So please listen to the full forms carefully. I'll be giving questions in the quiz based on the full forms only. Okay, in this discussion part I'll be asking you full form questions only, so please listen to the full forms carefully, and if you are not able to listen, you can go back and forth to the video to listen to the full forms carefully and then answer the questions. Okay, so PAM is pulse amplitude modulation, PWM is pulse width modulation, PPM is pulse position modulation. Okay, then comes unit 2, in which we will be studying pulse code modulation. The unit 2 basically comprises of the this thing low pass signals. It is mainly for the low pass signals that we use all these techniques. Okay, so in the first unit it comprises of basically some small parts, comprise of converting the sampling is basically a part of the process in which we convert an analog signal into a digital one. So in the second unit we will be seeing some of the modulation techniques which are used for low pass signals. So the pulse code modulation is one of them, in which we convert the analog signal into a digital signal. Okay, so sampling is we'll consider in unit 1, and pulse code modulation we'll study in unit 2. Sampling is a part of pulse code modulation. Then the second part of pulse code modulation is quantization, which we'll be studying in which we'll study in unit 2. Then there is quantization noise. When we perform quantization, there is some errors which are introduced in the signal. So that error is called quantization noise. Then companding. Quantization is of two types basically. One is uniform quantization and one is non-uniform quantization. The non-uniform quantization is termed as compounding. So we will be studying compounding. Then comes inter-symbol interference. Inter-symbol interference is when we are multiplexing the signals or symbols. There is some interference between them if we are not using the proper uh, frequencies, or we are not having proper parameters basically while transmitting. So we'll see what is intersymbol interference and how it can be reduced or removed. And then comes eye pattern. Eye pattern is basically used for visualizing patterns on the CRO. We'll see what it is used for and how we can use it as and when we go to this topic. Okay, then comes delta and adaptive delta modulation, adaptive modulation or adaptive delta modulation. So these are basically extensions of pulse code modulation. Pulse code modulation is extended to adaptive, sorry, not adaptive, differential pulse code modulation. Then that is extended to delta modulation, and the delta modulation is extended to adaptive delta modulation. We'll go through all these and see what all differences are there in between them. Then come encoding techniques. Encoding techniques help in sometimes help in various in the trade-off between various parameters like power, bandwidth, and all those things. We'll see what are the important parameters through which we choose the encoding techniques, different encoding techniques, and what are the advantages and disadvantages of these encoding techniques, and which places, which this in which of the places, or we can say which of the practical implementations of these encoding techniques. Okay, what are the practical implementation of these encoding techniques, like in which of the practical areas these encoding techniques are used. We'll go through that also, and then their advantages, disadvantages also we will study. The unit 3 comprises of basically band pass data transmission. So band pass data transmission, as I already told you, it is considered for higher frequency signals. Okay, so uh, this for in this the first topic we'll be studying is ASK, amplitude shift keying. Then there is BPSK, binary phase shift keying. QPSK is quadrature phase shift keying. DPSK is differential phase shift keying. Then comes coherent and non-coherent BFSK. BFSK is binary frequency shift keying. So BPSK, QPSK, and DPSK are very closely interrelated because all of them are phase shift keyings. So we'll see what all differences are there in them, and which one is used at which practical area. Then comes minimum shift keying. Minimum shift keying has one extension, namely Gaussian minimum shift keying, GMSK, which is used in mobile communication. So we'll see minimum shift keying, and if time permits we'll go through GMSK also, Gaussian minimum shift keying. Then comes QAM, quadrature amplitude modulation. We'll see what it is, and then we have some extensions or variations of PSK and FSK, which are MRE PSK and MRE FSK. We'll see what these two are and how they are useful in various places. Then comes spectral properties of QPSK and MSK. We'll see that also. Then comes unit 4. So the unit 1, 2, and 3 are different, and now that is the transmission part, and the unit 4 comprises of the receiver part. Okay, so the receiver part starts from the matched filter, which is used to improve the SNR of the received signal. Correlator detector is there, where we use the correlation to detect the received signal. Then we have Gram-Schmidt orthogonalization procedure, which is used for basically used for reducing the probability of error or the noise that is incorporated in the received signal. Then there is a computation of probability of error for different these modulation techniques like BPSK, QPSK, QAM, coherent BFSK, and we'll have the comparison of all the different modulation techniques so that we can come to a conclusion like which modulation technique is better in which area. Okay, and then next thing that comes is Unit 5. Unit 5 basically is related to the source encoding and the error correcting codes, that is the channel encoding. Source encoding is basically related to reducing the number of bits that are needed to transmit a particular symbol or particular signal. Then next comes the error channel coding. Channel coding is basically related to the error correction. So the errors that are introduced from the transmitter to the receiver are corrected by using the channel codes. Okay, so how all these things are done we'll see in Unit 5. There are other things also like the concept of information theory, entropy, which is the randomness of the signal, information rate. Channel capacity is a very important part. Channel capacity defines like how much of this bandwidth the signal can have so that the channel can easily transmit it from the transmitter to the receiver. It is the same like if there is a water pipeline, it can only transmit a particular amount of water from the transmitter to the receiver. In the same way, the channel also has some capacity. The Shannon theorem, Shannon-Hartley theorem, they define the channel capacity basically. So we'll see what are these theorems and what is channel capacity. Then there is a trade-off between bandwidth and signal to noise ratio. By trade-off we mean uh, if we increase one of the parameters, the other parameter will go down. Like if we increase the bandwidth of the signal to noise ratio will go down. If we decrease the bandwidth of the signal to noise ratio will go up. So they are inversely proportional to each other. We'll see how the trade-off works and what are the important values maybe if we can get between while studying this trade-off between the bandwidth and the signal to noise ratio. Then source encoding we have already studied. This is used to reduce the number of bits required to transmit a signal from transmitter to receiver. Then there is zero memory source, extension of zero memory source. It helps us in increasing the entropy basically. So we'll see why it is done and how it is helpful to us. Then there are error correcting codes. This is the starting of the channel encoding part. Error correcting codes are of different types like linear block codes and cyclic codes. Linear block codes and cyclic codes are very much interrelated. So we'll see what are the differences and what are the similarities. Then comes encoder and decoder circuits. We'll see how we can encode and decode code basically some data into linear block codes or cyclic codes. Then comes burst error correcting codes. Burst errors means a combination of errors or you can say a frame of errors or like multiple errors you can say. If there are multiple errors then we call it as burst error. We'll see how we can correct that, what kind of codes are used for correcting burst errors. Then the concept of convolutional codes. The convolutional codes are the most widely used channel codes for correcting errors and detecting errors. So we'll see what is the concept of convolutional codes also. The reference books comprise of Simon Higgins, which is the best book in the three of them. Most of the syllabus will be covered in this only. If some syllabus is not covered in the three books that are mentioned here, then I'll be giving you some other material or maybe some other book in which that part is covered. So we'll see as and when the syllabus progresses what part is covered and what part is not covered. The second and third books also you can refer, but I would prefer first one. Okay. So this was it for the in the discussion of the syllabus of digital communication. From the next class onwards, we will be starting unit number 5 because it is the easiest of the units and it has very less relation to the other 4 units. Like if we study unit 5 first, it is not at all related to what we are going to study in the first 4 units. So we'll be studying with unit 5 because it is the easiest one, and we should not be in a position to leave that unit. We'll study the easiest one first, and then we'll start with unit 1, 2, 3, and 4. So from the next class onwards, we'll start with unit number 5. So this was it for this lecture on digital communication. Thank you very much, students. Thank you.